Hello everyone. Today we will start numerical integration from numerical methods. So first is here we will discuss two formulas. One is trapezoidal rule, another one is Simpson's one-third rule, which are very important in numerical integration. So before going to derive the formula, first we should know general quadrature formula. So what is this? So first consider the definite integration I equal to a to b fx dx, this one. So here we divide the interval ab into n equal subinterval by the point x0, x1, x2, x3 up to xn, like this one. So if you take this one as x0, this one as xn, so we are dividing by n number of subinterval, like this way. Where xi equal to x0 plus ih. So that means here x0 to xn difference is h. So x0 to x1 difference is h. Same way x1 to x2 difference is h. So in this way you will get xi equal to x0 plus ih, where I equal to 0, 1, 2, 3, 4 up to n. And h be the length of each subinterval. Let y0, y1, y2, y3 up to yn be the values of y equal to f of x at the point x0, x1, x2, x3 up to xn respectively. So these are known as x0, x1, x2, these are known as arguments, and corresponding the values of y0, y1, y2 up to yn, these are called the entries. So first value is a, you will consider x0 equal to a and xn equal to b. So now I equal to integration a to b fx dx. So a equal to x0 and b equal to xn or x0 plus nh. So b minus a equal to x0 plus nh minus x0. So x0 cancel out, so it will be nh. So we can write either h equal to b minus a by n or n equal to b minus a by h. Next is let x equal to x0 plus UH. Okay, so dx equal to h du. So when the value of x is x0, so if we put here x0 equal to x0 plus UH, so x0 cancel out, here h equal to u. U equal to n, u equal to 0, and when x equal to xn, so xn equal to xn plus uh, so xn cancel out, so u equal to n. So that we have done here. Next is now from equation 2. So equation 2 means this one. Now from equation 2, so here h equal to 0 to n. So we know that there is formula from shift operator e to the power n f of x0 equal to f of x0 plus nh. x0 plus nh. So here, since here e to the power a, here a u is there, so here it will be, since here if you write here u, it will also u. So that's why e to the power u f of x0. Again, from the relation between shift operator and forward difference operator, we know that e equal to 1 plus delta. So e equal to 1 plus delta. So we can write 1 plus delta whole to the power u f of x0 du. So now the formula is, we will break it like 1 plus x to the power n, this one. We will break this one. So 1 plus x to the power n, so here 1 plus u delta plus u into u minus 1 by factorial to delta square plus u into u minus 1 u minus 2 by factorial to delta cube plus dot dot dot, then outside, and here we have written f of x0 equal to y0 because we know that yi equal to f of xi. So if we put I equal to 0, so f of x0 equal to y0. So that's why here y0. Now after integration, so since y0 is constant, so take common outside, so it will be h outside we have. So y0, no need to change y0. Then integration of du, that means u. So u and here u. So now the limit is n to 0 to n. So what we can write here, after putting the value, we can write here, this is n, because integration is u, and after putting the value 0 to n, it is n y0. So that is written here. Plus again, plus y0, no need to change since here delta is there. So delta y0, no change. So what is remaining? U du. U du means u squared by 2. U squared by 2. So after putting the value 0 to n, it will be n squared by 2. That is written over. Same way, first we have to multiply u square, like u square minus u divided by 2, and outside we have, and this one, delta square y naught. So delta square y naught, no change, delta square y naught, no change. U square by 2, after integration it will be u cube by 6, u cube by 6, because u cube by 3, 3 into 2, that is 6. So take common outside, you can write also this way, take common outside half. So what is only we have u square, so u square means u cube by 3, and after putting 0 to n, it will be n cube by 3. So that's why n cube by 3, this one. And remaining we have u, so u means integration u square by 2, so it will be n square by 2, this one. So we can write here n square by 2. So this way remaining terms also we will get. Okay. So now here after written this, just we have simplified here. H n y0, no change, this one also no change, just here we are taking common 6 outside, so it will be 1 by 12, and here taking common 4 outside, so it will be 1 by 20 for this one. So this is our equation. This type of equation is known as general quadrature formula for n plus 1 equidistant ordinate. So this is very important formula, because with the help of this formula we will get trapezoidal rule and Simpson's 1/3 rule. So next we will go to the trapezoidal rule. So from the previous formula, this is your previous formula, this one. So from the previous formula, how do you get trapezoidal rule? How do you develop trapezoidal rule? So by putting n equal to 1 in equation 3, you will get trapezoidal rule. So left hand side is, so integration here, so integration a to b, we know that a to b, so that this is your first integration formula. Just see, look at this, first formula is a to b, but a to b means initial value here x0, and here b equal to x1. Now question is why you have written here 1. Actually here formula is x0 plus nh, and here we will put n equal to 1, so x0 plus h, x0 plus h means x1. So directly we have written here x0 to xn, x1. So x0 to x1, that is your fx dx same. And now this one, how do you get? So here n equal to 1, so h y0 plus input half, so it will be half del y1, del y1. So here y del y1, so just see here, it will be del y0. There is some confusion, so just all of you look at this one, there is correction. So del h into y0 plus half of del y0, this is y0. So next one is after doing this, so y0, y0 no change. Now del y0, what is the formula of del y0? Already we know from the finite difference. So half of del y0 means y1 minus y0. So after simplifying, you will get h by 2 y0 plus y1. So this is for the interval x0 to x1. Next interval is just next interval is x1 to x2, x1 to x2. So f of x dx, and this one, since here x0 to x1 corresponding, so if you take x0 to x1, so corresponding the values of y will be y0, y1, so that's why here y0 and y1 involved. Same way x1 to x2, so here involved dependent variable is, independent variable is x1 x2, and dependent variable y1 y2, so that's why y1 y2. Just go to the next interval, that is x2 to x3, x2 to x3, so same way x2 to x3, so y2 to y2, y2 plus y3. Okay, so in this way the last interval will be xn minus 1 to xn. So here fx dx equal to This one equal to h by 2 yn minus 1 plus yn. Now, if we add all the above integrals, so first initial value is x0 and last value is xn. Just see here, fx dx no change. This one equal to h by 2 and just see y0 and yn, that two terms are single time. So we will write y0 plus yn plus 2 into, and now the remaining terms, just see y1 y1 two times, y2 y2 two times. So same way yn minus 1, this is also same two times. In previous interval we got also yn minus 1. So after counting this, so remaining terms are two times, so that's why plus 2 into remaining terms. So this is known as composite trapezoidal rule. Next is Simpson's one-third rule. So same way, if we put n equal to 2 in that equation, that is new general quadrature formula, you will get x0 to x2. Why here x2? Because we know that x2 equal to x0 plus 2h. Since n equal to 2, so we have written x0 to x2. So after calculation, you will get 2h y0 plus del y0 plus 1 by 6 del square y0. So keep in mind, in the previous case we have where x0 to x1, so only involved values of y are y0 to y1, no need to take y2. So that's why here we have taken two element. Same way in Simpson's one-third rule, here involved the independent variables are y0, y1, y2. So whatever the involved are y variable y0 y1 y2, we will take up to that element. If the next element which can include y3, so we will neglect that term. So up to y2 element we will take. So just see, if we take the del cube, so del cube next term will be del cube where y3 will involve, so that's why we will neglect. So only these three terms we will take. So after calculation, you will get h by 3 y0 plus 4 y1 plus y2. In the next interval, just two difference, so x2 to x4, so h by 3 y2 plus 4 y3 plus y4. Next again interval x2 x4 to x6, this one. So in this way, the last interval xn minus 2 to xn, because two difference, so fx dx equal to, this one equal to h by 3, and so here y4 is there, so here yn minus 2 plus 4 into yn minus 1 plus yn. So this is the last term. So adding, if we add all the terms, all the integrals, so here initial value is x0 and last value is xn, this one. So h by 3 is common, so take common outside h by 3, and the just see that y0 and yn, these two terms are only single time, so this one, and y1, the odd terms y1, y3, y5, yn minus 1 are 4 times, so you will write 4 into this one, and the remaining term means even terms like y2, y4, y6, yn minus 2, these are 2 times, so that is plus 2 into remaining terms. So which is known as composite Simpson's one-third rule. So in this way, we can easily get trapezoidal rule and Simpson's one-third rule from the general quadrature formula. Next is estimation of error in trapezoidal rule. So this is a formula of error in trapezoidal rule, ET equal to minus of h square b minus a divided by 12 f double dash fx. Okay, so this is the error term, and here rule error involved order of h square. Next is some notes are there regarding trapezoidal rule, which is very important. Trapezoidal rule is applied for any case of subinterval, whether it may be even or odd. On the other hand, trapezoidal rule error involves, just see here, error involves second order. This one second order. Error involves second order derivative of the function fx. So it gives the exact value of the integral if fx is constant or first degree polynomial. So the degree of precision of the formula is 1, which is very important. This is for short question, broad question, and for viva voce of the practical. The degree of precision of the formula is 1. Estimation of error in Simpson's one-third rule. So Simpson's one-third rule here error is minus h to the power 4 b minus a by 1 80 f to the power 4 x. So here error involves fourth order. So that's why here order of 4. Error is order of 4. Next is notes. So Simpson's one-third rule is applicable when the subinterval is even. So this is the difference between a trapezoidal rule and Simpson's one-third rule. So trapezoidal rule can be applied for two cases, even or odd, but Simpson's one-third rule only applied for the even number of subinterval. Next is in Simpson's one-third rule, the error involves fourth order derivative. So already we have seen this is fourth order derivative. So Simpson's one-third rule error involves fourth order derivative of the function fx. So it gives exact value of the integral if the polynomial of degree less than or equal to 3. So the degree of precision of the formula is 3. So again there is difference between trapezoidal rule and Simpson's one-third rule. Trapezoidal rule degree of precision is 1 and Simpson's one-third rule degree of precision is 3. Next is geometrical interpretation of trapezoidal rule. So here we have taken just see here, this is your integration a to b fx dx. Actually here it represent the trapezium, the area of trapezium. Okay, so if you take a0 this is your initial value x0, this is your last value x1. So here the graph y equal to fx replaced by the straight line, and this is equal to the area of trapezium. So that's why the another name of trapezoidal rule is trapezium rule. Next is geometrical interpretation of Simpson's one-third rule. So Simpson's one-third rule here, the curve y equal to fx replaced by the second degree parabola which is passes through p0, p1, p2. Okay, so again there is difference between trapezoidal rule and Simpson's one-third rule. So in trapezoidal rule, the curve y equal to fx replaced by the straight line, and here the curve is the area of the curve y equal to fx is replaced by the second degree parabola. Now the problem is there. So there is problem. Evaluate 0 to 1 a 4x minus 3x squared dx taking 10 interval. 10 interval means here n equal to 3 and it is even. So by trapezoidal rule and Simpson's one-third rule, compute the exact value, find the absolute and relative error. So function, what is given here? Function is given, that is 4x minus 3x square. This is the initial value. This is the terminal value. So a equal to 0, b equal to 1, n equal to 10 is given. So a, b, n is given. So we can easily find out h. What is the formula? B minus a by n. So 1 minus 0 divided by 10, that is 0.1. Now the most important thing is the tabulation values of fx and corresponding the values of x. So since the initial value is 0, so we will start with 0. Then increment is 0.1. So 0.0 plus 0.1, that is 0.1. Again 0.1 plus 0.1, that is 0.2. 0.2 plus 0.1, 0.3. So in this way you will reach at 1.0 and you will terminate here. You will stop here 1.0 because here last point is 1. Okay, so we will take up to 1. Next, corresponding values of x, you will find the values of fx. How do you find? Just put the value of x in the function 4x minus 3x square, you will get the value. So in this way, corresponding all the values of x, you will find fx. Now the trapezoidal rule. So already this type of problem, first we have to write the formula, because for correct formula you will get if the question is 5 marks question, so for the correct formula you will get up to 2 marks. So whatever the calculation, first write down the formula neat and clean. So h by 3 y0 plus y10 plus 2 into y1 plus y2 plus y3 up to y9. Now the question is why you have written here 10. Y0 is okay, that is the initial value. What is the meaning of y10? Actually there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 values are there. So here y0 value and here y10 value. So if you take y0, y1, y2, so that is y10. So y0 plus yn, because we know that for trapezoidal rule, first value plus last value and plus 2 into remaining value. So this is y1, y2, y3, y4, y5, y6, y7, y8, y9. So that's one, y9. Okay. So after getting the formula, you have to just put the value. So you will get the answer. So this is the, after just apply the formula, apply the data from the previous table, you will get the answer. So this is one part. Next part is compute the exact value and find the absolute and relative error. So exact value means just direct integration. So this is your direct integration, and now the absolute value is exact value minus approximate value. This is your actually approximate value, that is the calculation value, calculated part. So this one, absolute error equal to exact value, this one, and minus of this one. So you will get this one 0.005. This is your absolute error. Now the relative error, and the relative error formula is absolute error divided by exact value. Absolute error is 0.005 and exact value is 1. So you will get 0.005. Okay, so this is the trapezoidal rule. Next is Simpson's one-third rule. Same way Simpson's one-third rule. So just see that here y0 plus y10. So we have written here y0 plus y10, this one. Now it will be better if you mention here y0 and y10, and this one y1, y2, y3, y4, y5, y6, y7, y8, y9. So already we have taken, and keep in mind we will take single time. So y0 and y10 already we have taken, so we will cancel out. Next is plus 2 into just see 2 into even terms plus 4 into odd terms. So 4 into odd terms. So odd terms you will mark as circle y1, y3, y5, y7 and y9. And even terms you will mark as that is square y2, y4, y6, y8. So if you mark this way, there will no missing data. So just now you will put here, and after this you will get the value, and the value is you will get 1.000. Okay, so this is the first part. Second part is exact value also 1. So absolute error, there is no error actually. Absolute error equal to exact value minus approximate value, so that is 000, and the relative error is absolute error divided by exact value. So we have 000 divided by 1. So that is your 0.005. Okay. So in this way, we can easily find out trapezoidal rule and Simpson's one-third rule. So here in this problem, it is mentioned here, we have to apply trapezoidal rule and Simpson's one-third rule. But in sometimes we have seen there is no specification, just question is given and apply the numerical integration, or apply trapezoidal rule or Simpson's one-third rule with the help of appropriate reason. So first we have to check how many intervals are given. It is even or it is odd. If it is even, we can easily use trapezoidal rule and Simpson's one-third rule, and if it is odd, strictly we have to use trapezoidal rule. So keep in mind this. Okay, so there is a few more question, that is for your solution you will solve yourself. So that is evaluate 0 to 5 dx by 1 plus x by trapezoidal rule, taking h equal to 1. You will get correct up to 3 decimal places. Another question is there, by Simpson's one-third rule, correct up to 2 places of decimal, taking 3 points, taking 3 points. So n equal to 3 here, and h equal to 1. So in both the cases here, just see taking 3 points. So keep in mind here Simpson's rule is applicable or not. Okay, so all of you find and just think over this, taking 3 point, and you can use Simpson's one third rule or not. Okay, so this is for your homework. Okay, so till then all of you bye. Again we will meet with next class, new topic. Okay, till then bye all of you.